Now let's talk about kinetic friction. See, when we talk about kinetic friction, see, and take an example. Let's say you're trying to push the same 5 kg of that cement block was there, no? So you're trying to push it. See, initially what happens? You'll keep on pushing it. It doesn't move. That is because of static friction, right? Now, once you give enough force for it, now what happens? It starts moving, correct? Correct? It starts moving. So what happens is, as you keep on moving, because of the surface and the body, there is a friction which is acting on the body, correct? Even though that is moving, even though there is some kinetic motion of the object, still friction exists there, right? So this friction is what we call as kinetic friction. Okay, kinetic friction. Now, see, when it comes to kinetic friction, so what you have is, you have something known as coefficient of kinetic friction. Okay, we call it as mu k. Alright, and also it depends on the normal. Alright, so see, you have been seeing in the figure, right? So you have been seeing in the figure. So whenever an object moves, okay, whenever an object moves, there is always kinetic friction. See, let's take different examples you will see. Okay, best example is, you are walking on a floor. That is because of friction. Okay, that is because of friction. But in this case, it's not kinetic friction, actually it's the static friction. For example, see, you have to run very fast. Okay, if the floor was very slippery, can you run? No, right? It's not possible. Because of static friction, that static friction stops the leg and then you move forward. It's the reaction what is happening. Action is the friction, the reaction is you running on the floor. So friction is helpful almost everywhere. Everything in this world works because of friction. You're walking, you're running, or an object is moving. Cars and trains and all these things, they'll stop because of friction. Okay, all these things are mainly because of friction. Now, if you're running or when you're walking, it is actually static friction. Now, a car stops, right? So the car is moving, it stops because of the brake. That is because of kinetic friction. Okay, so there is friction and car is moving forward. That is also actually kinetic friction because the tire is in contact with the road. If the road was very slippery, then even if you press the brake, what happens? You'll just slide. I think you guys must have seen all these things. There is a ice road and people put the brake and then the car starts sliding and collides with everything. See, there is no friction. If there is no friction, you cannot stop an object. Okay? So let it be kinetic friction or let it be static friction. See, these are all examples what I am telling. Now, for static friction, remember we did a formula, an empirical formula. Same thing, even for kinetic friction also we have an empirical formula. Okay, so we have Fk is equal to mu k into n. Fk is the kinetic friction, mu k is the coefficient of kinetic friction, and n is the normal. Okay, so these are the three things. Now see here, look at the graph. So this part of the graph is basically your static friction, then comes the kinetic friction. Okay, so this is how the graph looks like for a kinetic and static friction. Now, so carefully study the graph. Okay, so look at the graph. So take your time, study the graph carefully, look how the force you are applying and how much of distance is it moving. If you can look at it, static friction is more compared to kinetic friction, right? Static friction is more. That's always the case. See, you must have experienced it practically. For example, let's say you have to move a table. Okay, so on the table, let's say you have some weight on it. Initially, if you have to push the table, you have to apply a lot of force. Once it starts moving, then it's easy for you to push it, correct? So that's because the static force, the static friction you can say, the static friction is much higher compared to that of kinetic friction. So if you look at the graph, you can clearly understand it. Okay? Fine with this? So in the next video, you are going to see few more examples and problems on friction.